Normally in math class, you expect to do this thing called math, but instead we're doing things like consistent and inconsistent, dependent and independent. How is this math? So here's our first example. Instead of finding the answer to this, like two numbers for x and y, we instead need to figure out if this is consistent or inconsistent, and if it's dependent or independent. But what does that even mean? First of all, let me share with you what consistent and inconsistent mean. So if you wanted to find the actual math answer to this, you wanted to find x and y, you would plot both of these equations on this graph and draw the two lines, and then wherever they intersect, like right here, that would be the answer to x and y. But in this case, we don't have to do that. In this case, we just have to tell if it's consistent or inconsistent. Consistent basically just means that there's at least one answer. In this case, there is an answer. See, it's right there. So this would be consistent. So how can two lines not have an answer? How can it even be inconsistent? Well, this is an example of an inconsistent graph. You have two lines here, but you may notice that they're parallel, which means that they have the same slope and they are never going to cross each other, ever. So these will never have an answer, so this is inconsistent. Now, if the graph is inconsistent, that means that that's it. There is no dependent or independent. It would just be inconsistent. But if it is consistent, then you have to tell if it's dependent or independent. So going back to a graph like this, where they intersect at somewhere at one spot, this would be considered independent. This would be independent because they cross at exactly one point. So how can they not cross at exactly one point? Well, something like this would be an example of crossing at more than one point. And you might be asking yourself, wait, but there's only one line there. I thought this was having to do with two lines. Well, actually, this is two lines graphed right on top of each other, so that it's literally just one line. If you imagine this as two lines on top of each other, they cross each other at every single point here, as in an infinite amount of points. So in math, we would call this infinite solutions, or you would call this consistent and dependent. So here's a little chart here that will help you remember this, and you can always just take a picture of this or whatever and just reference it for when you're doing the problems. So let's go ahead and do this first example. We have y equals 2x minus 2 and y equals negative 2x plus 1. Well, to see if they cross and at how many points they cross, we need to first graph them. If you're not quite familiar with graphing lines, I have a video in it that you can watch on the card on the screen right now. And if you want, you can go watch that one first and then come back here. But I'll also quickly review what we're going to do. We need to use y equals mx plus b. So remember that these two equations are in y equals mx plus b because y is by itself, and we have a number for m and b. And m is the slope, and b is the y-intercept. So looking at our first equation here, y equals 2x, 2 is in the place of m, so 2 is going to be our slope. And here, negative 2 is b, not just 2. Remember, the negative sign has to stay when we're doing things like m and b. So b is going to be negative 2, our y-intercept. So let's do our y-intercept first. We have negative 2 here, so we're going to start in the middle and go down 1, 2. This will be where it crosses the y-axis, this big vertical line here. And now we need to do the slope. Remember that slope is rise over run. So in this case, our slope is 2. So we're going to put 2 for the rise. And since it's not over any number that isn't over anything is just over 1. So our run is going to be 1. So let's go ahead and do our slope. We are going to rise 1, 2, and we're going to run 1. So we're going to put another point here. And if you wanted, we could do that one more time just to help us draw a straight line. Rise 2, run 1. So now we just need to draw a straight line between these points, and that's going to be the hardest part. Well, there we go. Now we have a straight enough line, and that's the line of y equals 2x minus 2. But now we need to plot y equals negative 2x plus 1. So to do this, we'll do the plus 1 first, which is b, right? We're going to do the y-intercept. So plus 1, we're going to start in the middle and go up 1. And now we need to do the slope. In this case, the slope is negative 2. That's what's in front of m, but it's not just 2. We have to include the minus sign as well. So that means our rise is going to be negative 2, as in we're going to be falling because it's a negative number. And our run is just going to be 1 because there's still no number under this, so it's just over 1. So we're going to fall 1, 2, and run 1. Now let's draw a straight line, or at least try to. So there we go. We have our line of y equals negative 2x plus 1. So now our final part is we need to figure out, is this consistent or inconsistent, and is it dependent or independent? Well, first of all, we have to ask ourselves, do these lines cross at all? If they don't cross at all, then that's going to be inconsistent and we're done. But in this case, these lines do cross each other right here. So that's going to make this consistent. So if the graph is consistent, then we have to ask ourselves, is it dependent or independent? And remember, independent means one, as in it's got one answer. In this case, it does have one answer. It would have been dependent if they had infinite answers. So this is going to also be independent. So that's it. Our final answer is consistent and independent. And if you wanted to also solve for x and y, you would just figure out the coordinates at this point here. But it looks like it's going to have a lot of fractions and stuff, and no one wants to deal with that. So here's another example. What I'd like you to do is go ahead and pause the video, try to graph these yourself, and then determine if it's consistent or inconsistent, and dependent or independent. And then go ahead and unpause the video and see how you did. Okay, so we need to graph these two lines. And the first thing I'm noticing here is that one of these lines doesn't follow y equals mx plus b. In y equals mx plus b, y is by itself here, right? And that seems to follow this equation, but this bottom one, x is by itself instead of y. So we need to fix this equation to be able to graph it. In this case, I see y has a -1 attached to it. So we can get rid of this -1 by doing the opposite of -1, which is +1. So we're going to add 1 to both sides. These cancel out, and on this right side, we're just left with y. And on the other side, we added 1 to x, which you can't add a letter in a number, so we're just going to leave it as x plus 1. And now you see this does follow y equals mx plus b because y is by itself. It's just kind of weird that y is on the right side. So what we can do is just flip these two sides around. That'll still be true. So we now have y on the left side and x plus 1 on the right side. You didn't have to do this, but it makes it look more like y equals mx plus b. So y equals x plus 1 is going to be our equation, our second equation that we're going to graph. So let's go ahead and graph these two lines. And you may already be noticing that these equations are very similar. So you might be going, oh, maybe this is going to not be just consistent and independent. We'll see. So first of all, let's graph the y-intercept. In this first equation, the y-intercept is -1 because the minus sign is involved. So we're going to start in the middle and go down 1. Now we're going to graph the slope. Remember, slope is rise over run. And in this case, we don't have a number in front of x. So we can imagine that there's a 1 in front of x. That's what you can always do when there's not a number in front of it. So our rise is going to be 1. And because there is no number under this, then it's just over 1. So our rise and run are both going to be 1. So we're going to rise 1 and run 1. And we can do that again if we wanted, rise 1, run 1. And now we can draw a line in between these. So let's try to do that. So there we go. We have our line of y equals x minus 1. But now we need to draw the line of y equals x plus 1. So our y-intercept is going to be +1, just 1. So we're going to start in the middle and go up 1. And now we need to figure out our slope. In this case, our slope is going to also be 1. So we don't even have to erase this. This is the same. Our rise is going to be 1, and our run is going to be 1. So we're going to rise 1 and run 1. And then we can do that again if we want. We can rise 1 and run 1. And now let's go ahead and draw a line between these, and you may already be noticing what our answer is probably going to be. So there we go. We have our line of our second equation. So now we need to ask ourselves, is this consistent or inconsistent? Well, in this case, we don't have any crossing of the lines. But you may be asking yourself, okay, well, maybe these just go on and they cross somewhere off of the graph. How can you tell that these aren't going to cross off like 100 squares away? Well, you can tell that because they have the same slope. If two lines have the same slope, they are never going to cross each other like this. So in this case, this is going to be inconsistent, because remember, inconsistent means that there are no answers to this problem if we were to try to figure out the numbered answers. So now, is it dependent or independent? Well, remember, if it's inconsistent and there are no answers, then it's neither. It's not dependent or independent. So in this case, our answer is just going to be inconsistent. We don't have to do anything else. So that wasn't so bad, was it? You didn't even have to figure out any numbers for your answer. But if you're like me, you probably don't like graphing as much as just other parts of like actual math. I mean, maybe you like graphing, I don't know, it's up to you. But what graphing lovers and graphing haters can agree on is that there are faster ways to solve these systems of equations. And there are two main methods, substitution and elimination. If you want to learn the first one, substitution, then you can watch this video right here. And as always, if you have any questions, just go ahead and leave it in the comments and I'll be sure to answer it. Thanks for watching.